Okay, now we're going to move on to example 5. On example 5, it wants you to sketch this graph. So they just do it using the table method, I believe. So I think before we do that, though, let's talk about roughly what this is going to look like. So we know the bottom has to be positive, and if we do 1 divided by a positive number, we will always get a positive. So this function will always be positive. And so nothing's going to happen down here on the graph. Another thing we know is there's no way to get an asymptote because there's no way to make the bottom 0, which happens often when things are set up this way. So really, after that, it's just plugging things in. So if we have x and y, for example, I'll just start at 0. If I plug in a 0, I'm going to get 1 over 0 squared plus 1, which is just 1 over 1, which gives me a 1. If I plug in a 1, this bottom's going to become a 2, so it's 1/2. If I plug in negative 1, same thing is going to happen. Negative 1 times negative 1 gives us a positive 1 plus 1, so we get another 1/2 right there. So I think I'm just going to rewrite that as plus or minus right there. And let's try plus or minus 2, because the same thing will happen if I plug in a positive 2 here or a negative 2. We'll get a 4 right here. 4 plus 1 is 5. So we end up with 1 over 5. Now if we come over here to graph at x equals 0, y equals 1, we put a dot. Negative 1 and positive 1 give us a 1/2 value. Negative 3, positive 3 give us a 1/5 value. And that gives us enough information knowing that it's going to be always positive. So it's going to kind of go like this. And we do have a horizontal asymptote. When I was talking about asymptotes earlier, I think I misspoke. I meant there are no vertical asymptotes created by division by 0. All right. Let's move on to the next example. So this is example 6. So we're given a figure, and it's a parabola that looks roughly like that. Look in your book if you want to see a better drawing of that. And it's defined as y equals x squared, or specifically f of x equals x squared. And then it says figure B is a horizontal and vertical shift of A. What is the equation of B? So this is our A, this is our B, and it looks like it's been shifted over to the right 1 and down 1. It looks something like that. So we just need to state what the equation would be. So if we move to the right, what's going to happen is it's actually counterintuitive. We subtract something from x. So if we go this direction, we subtract from x. If we go this direction, we add something to x. You just have to remember if it's left and right, it's going to be counterintuitive. Now, when we're going up and down, if we go this way, it's positive, and this way is negative. So this one's intuitive, and that's what we're going to just tack on to the end. Well, whoops, not that. So we went down 1, so we're going to subtract. And then we can just call this y of x or g of x or whatever we want to call it. Okay. I think that's it on that one. Yep. And there's one more example. So we have example 7. This time it says sketch the graph of f of x equals sine pi x. wants us to do f of 3x and 3f of 3x. Or no, not that. Just 3f of x. And that's it. Okay, so sine of pi x. Let's just start with sine of x actually first. We'll take one step back from what the problem's asking us to do to make sure we can remember this. Okay, so this is 1, this is negative 1, this is pi, this is 2 pi. Now, when we change stuff inside here, so we have an extra pi. Once again, this was just sine of x. If we have an extra pi, what we do is we take the current period, so in this case, period is equal to 2 pi, and we divide it by whatever that's being multiplied by. So our new period, those pi's will cancel, our new period is 2. So if we graph sine of pi x, we're going to get something that looks like this, but this is going to be at 1, and this is going to be at 2. Now, your book, you can look at it, they extended another period, and it ends up looking like this. So this would be 3, and this is 4. This is still at 1, and this is still at negative 1. All we did is, kind of stretched it or compressed it. I guess in this case, we compressed it. And that's all we have to do for that part. Now, if we do f of 3x, so just to be clear, that's saying sine of 3 pi x. We're going to go through that same process with the period. We're going to take the original period, divide it by the new thing that's out in front, and this time our new period is 2/3. So if we graph that, we can draw it exactly the same, but we just know that the full period is going to be 2/3, and this is going to be half of that, so that's going to be 1/3. Once again, the max is still 1, and the min is still negative 1. This last one, running out of room, but we're going to say sine of pi x, and then all of that's multiplied by 3. So if we just look at the horizontal part, it's going to be exactly like this one. Now, what the 3 is going to do in this case is it's going to affect these maximums. So once again, our period is still just 2, but we're going to go up to 3 high and negative 3 low. It's going to go like this. So like where it hits the x-axis, it's still going to be the same, but the amplitude, or how tall it is going to be multiplied by 3. If you need additional help, come to Math Lab. Until then, calculator.